Okay, welcome to class. A couple things on Learning Suite that I want to make sure we're good on. So first is that, first, the whole syllabus quiz. It just turns out I had never published the quiz. So that quiz is published now. I think I gave you way too long to take the syllabus quiz. Like, it's not due till the end of the month. Don't wait that long. But anyway, get it done. Oh, in fact, I hope you'll do it a lot sooner, because the last question in there is a release that actually allows me to publish. If you ask a question in class, gives me the right to publish that video beyond the scope of just this one section. Okay, this link is going to be important. So files and videos for this course. So when you follow that link, it just takes you to the blog. And here's where on today, if there was a file that you should download to get ready for class, if you want to work along, with me in class, that's where the file will be posted to download. There's nothing here. In fact, we won't be doing a whole lot in VBA today. It's more conceptual today, but then other links that might be interesting down here, this presentation on variables. So today it's my goal to really get you familiar and comfortable with data types and variables in VBA. And even if you've come to me kind of already as an experienced programmer, my guess is you don't really grasp what a variable is, and I'm hopefully going to give that to you today. Any questions then, administratively, before we continue with today's content? Yes. Wait a minute, Stephen. I so very rarely can call on a student by name in this class that if you ask a question after giving the prayer, maybe 50-50 chance I'll remember your name that long. So Stephen, go ahead.
With the exams for those two, and they're like, what another multiple choice type of questions? It could be like textbook kind of questions where whether or not we understand like the definition of X, Y.
Yeah, so here's the question is, for the recording, the question is, we got a midterm and a final coming up, and I'm a little nervous about that. Really, what should we be studying for that? And the answer to that is, I'm going to give you, for both of those, I'm going to give you like a review. It's probably already published. So as we kind of get closer to this exam, there's going to be a document that's going to tell you kind of the review guide. And the way that I make the exams, I think, all right, I got to go through all the stuff that we've gone through, and I got to think, all right, what do I really want to make sure the students understand? And I'll put that in the review guide. And then once I've got the review guide made, which I've already made, I will go through and say, all right, here's a point in the review guide. How do I write a question from that? So I'm really making the exam from the review guide. So that's going to be kind of where you want to look. I wouldn't stress over that just yet, but you'll kind of, once you've got a little more road under your feet, you'll get a feeling for the kinds of things we're covering. And you should realize that I'm going to focus on what we do in class. If there's something in the book talks about that we don't talk about in class, is that going to be on the exam? That means I didn't even think it was important enough to bring up in class. I definitely don't think it's important enough to put on an exam. Okay. So does that help?
Yeah, that's what I want.
Okay. Yeah. All right. Other questions, administrative questions? Go in the back, go ahead. Oh, if only I had a TA who could update my educator due dates. Thank you. I've just forgotten to update those. And will you send me an email? Just gov@byu.edu, and I will assign my newly hired TAs to update those. Thank you. The Learning Suite ones are correct. Yeah. And in fact, it probably means they're old due dates. So if you submit now, you're going to get points deducted. Don't submit. Let me at least get the ones updated for the next few assignments. I'll try to do that today. Question here? So the question is, will the exam be timed? And the answer is, you'll have from the time you get it until the testing center closes for that day. So if you check it out shortly before it closes, you'll have time constraint. If you check it out in the morning and bring a lunch, you got all day. So yeah, and usually the fastest people to complete the exam do it in about 30 minutes. Average is about 45 minutes. And there's some folks that do make a day of it. I don't know. They just think they love the exam experience so much. Like, I want to savor every moment of this. I don't know. What are we going to do if they close the testing center and such? I don't know. We'll have to figure that out. Other questions? Yeah, actually, I do know what we're going to do if they end up closing the testing center. If they do by like halfway through, we'll switch. Instead of doing an exam, it'll be a project to have you do at the end. But it'll hopefully by the time we get midway through the course, we'll know if we're going to be able to kind of make it to the class this semester in person. So you'll have plenty of time on that. Other questions? Okay, so let's talk about then variables and constants. This is like a fundamental idea in programming that is it's like common across every language. Is there any programming language at all that doesn't have the concept of a variable? If there is, I've never heard of it. Yeah, there probably is somewhere. I don't know what it is. And so this is like fundamental across kind of every environment. So if we ask ourselves in the physical hardware of the computer, where is the one place that you can store a value, let it sit around for a while, and then call it back, kind of for immediate access? Now, I'll tell you the place I'm not talking about is the hard disk. So that's what we would call that stable storage. We put that out there and we lose power and it'll sit there. But what's the place that we have stuff kind of readily accessible to be processed? What's it called in the back? RAM, random access memory, yeah. And so that's what we're trying to figure out how we can manipulate. So this is what a RAM chip looks like, inside a computer. We actually have to figure out how to plug values so they'll sit on those chips while they have power and be able to access them, pull the values back, and so forth. Back in the very early days of programming, when we had memory that we could store a value in and retrieve it, it was really difficult to do. Every little place that we've got, lots of different places that we can store ones and values in memory, ones and zeros in memory. In fact, how much memory do you have on your laptop? Who's got a laptop that they've just kind of recently purchased? Tell me how much memory you have on it if you know. Anyone? Go ahead. No, okay, so that's your storage. So you got 16 gigabytes of RAM. 16 gigabytes of RAM is a crazy amount of, it'd be good if I could say like right here, if you were to print the Book of Mormon on 12-point font and you stacked it up, page after page, how many copies of the Book of Mormon, or how high would 16 gigabytes full of the Book of Mormon go? How many copies would it be? It would be a lot. I don't know what it is, but it's a crazy amount of data. So what is that? So let's see. So a byte is basically, it's one character per byte. And then you've got 1,000 is a kilobyte. And then you've got a million is a megabyte and a gigabyte, 16 million. I don't know, it's a lot. So, and the truth is, out of all those locations, every single one of those little ones and zeros that you can store in there. And by the way, when you say byte, that has 8 little individual ones and zeros that make up that byte. So when you say, I've got 7 bytes or a kilobyte or a megabyte or a gigabyte or a terabyte, each one of those has individually 8 little ones and zeros you can turn on and off. And every single one of those ones and zeros, every single one of those memory addresses, locations in memory that you could store a 1 or a 0, has an address. So what's the address of that little 1 or 0 in there? There's an address for that. In fact, when we talk about your operating system as being a 32-bit operating system or a 64-bit operating system, have you heard these expressions before? So what does it mean to have a 32-bit operating system? What it means is that operating system says, all right, our memory addresses are going to be 32 bits long. So, how many different, in a 32-bit operating system, how much memory can we address? Because every little 1 and 0 has to have its own address. And we only have 32 ones and zeros that we can use to say what are the addresses of all the rest of the ones and zeros. And that means in a 32-bit operating system, you can only address 4 gigabytes of RAM. Just because you don't have the naming space isn't any bigger than that. And of course, when we first made the 32-bit operating systems, we thought, wow, how 4 gigabytes of RAM, who would ever need that? And so, of course, as you get further along, we go, we're going to need more. So now we can address with a 16-bit operating system. I don't even know how much you can address with a 64-bit operating system, but it means you've got the addresses are longer, which means you can address more, a lot more memory. So that's what the 32-bit, 64-bit. When I started, it was 8-bit operating systems, which wasn't much at all. Okay. So, but kind of if we were to look into that memory, it's not really ones and zeros. It's some way of representing on and off electronically. And so if we're to kind of look into memory, this is what it looks like. It's just a long sequence of ones and zeros. And we somehow have to be able to hook into that in a way that is kind of easy for us to say, hey, operating system, we need some memory. Back in the early days when we were addressing memory, the strange thing to think about is that you didn't ever have 2 programs running at the same time. And today, you probably have 4 or 5 programs running that you don't even know are running. in the background of your computer, doing kind of various things. And then you might have another dozen or so that you keep running. How many would you say you've got, more than 10 programs that you have started just kind of running on your computer? Yeah, so it's kind of several of us right here. Back when I started with this, no. There's just one program running at a time. And in that context, imagine, there's only one program running. You could just say, I'm the program running. I have access to all the memory. There wasn't that much. I have access to all the memory. And so, I could actually think about going to a specific place in memory and saying, that's the part of memory that I want. Well, what happens if you now have two programs running at the same time and they're trying to address memory, the physical location of the memory? What would happen if two programs were trying to use the same part in memory? Well, you'd be doing, if that was allowed, you'd be doing something in Word, you'd change the document in Word, and it would go great. And then you go back over to Excel, which was using that same physical part of memory, and you would have changed the numbers in your worksheet on Excel because you changed something in Word, because the two would be conflicting with the same memory. So we don't ever say that's the specific location of memory that I want. Instead, application programs ask the operating system. They say, I'm going to need some memory. And the operating system says, here's some memory. And the operating system then remembers, I gave that memory to Excel, or I gave that memory to Word, or I gave that memory to Chrome. And what happens if some other program tries to access that memory? The operating system will kill that program. We'll just terminate it. You tried to access memory that I didn't give to you, that's a no-no. And so the idea here is that what we're about to see is how do we tell VBA to request some memory from the operating system and then to keep track of that for us to be able to put a value in it and then later come back and refer to it. So a variable is a location in memory. It's a physical location in memory with a name. Now the name is the part you choose. You don't want to have to think about it as an address, some 32 or 64-bit strings of ones and zeros that says that's where that memory is. You don't want to think of it that way. You don't even want to think of it as a hexadecimal number, which would be shorter, a base 16. You don't want to think about it as a base 10, a decimal number either. You want to think about it as a name. So you want to say, I'm gonna record something about the employee's name. I'm gonna call it emp name. And you'll say, hey, operating system, give me some memory. And the operating system is great, here's some memory for you. Well, you'll actually say how much you want. Give me 4 bytes of memory. And it'll say, okay, we've allocated those 4 bytes of memory. And then VBA is going to keep track of the connection between the name that you give it, the variable name, and the address. So the location in memory that you give a name to, where a value of a particular type, that'll be important to us here, can be stored and then retrieved. So it's just a place to put a value, let it sit around until we need it again. We've collected some information from the user, typed it in. Later in whatever process we're doing, we've got to remember, that's the information they gave us. Now we're going to actually use it. Okay, so questions on what a variable is. A lot of times when we're trying to just kind of introducing you to programming, and by the way, this is really an introduction to programming class. So if you have like experience, let's say you have experience in some other language, just raise your hand and say, I've programmed in some other language. Okay, so it's maybe half of you here. So there'll be times like today when I'm going to spend an hour talking about what a variable is. And you're going to be like, he's going to really talk that long about what a variable is? Because I know what a variable is. Check your email, or something. Don't disturb your neighbor. But if you feel like you got it already, that's okay. Kind of check it out. If you want to leave, it wouldn't hurt my feelings either, because you could fast forward me later on the video. But this class is really meant to introduce people that have never programmed before. Now, here's the good news. There are going to be some things about VBA that are different enough from whatever language you programmed in before. I should say this. Here's the good news for the people that have never programmed before. There's going to be some things that are so different about VBA that the people who have already programmed before will be at a disadvantage, because it's going to be totally different. They're going to be like, oh, wow, that's unexpected. But it'll just be natural to those of you who are learning with me today. So, okay. So that's what a variable is. The smallest set of memory that we address with VBA is a byte. There's no way that we can look at less, kind of get less than a byte of information. And so a byte is just 8 bits. What's a bit? Bit's a binary digit. Bit is short for binary digit. It is just a 1 or a 0. And everything, of course, has to get stored as a 1 or a 0. So a big part of kind of how we work with variables is, and really understanding what's going on with the variables, is how do we get from that set of ones and zeros into what it is that we actually want to represent in kind of the values, whether it's numbers or dates or times or names. How do we get there? So the byte is going to be the smallest one. So let's suppose we just have one byte here. And so it's these zeros, but this is the way it works, is that kind of, here in binary notation, we then say, all right, we have one of these bits that represents the ones column, one that represents the twos, the fours, and so forth. So this is 0. If all of my bits are 0, the number, kind of the number that's represented there in binary is 0. And then, there's 1. That's 2. Now, 1, you look, okay, it's got 1 in the 1 column. So why is this 2? Because this says you have 1, 2, you have 0 ones, you've got 0 fours, you've got 0 8s, you've got 0 16s, and so forth. So what is that number that we're showing right there? 1 0, what is that number in binary? That number, 1 0, represents the quantity 2, yeah. In fact, it kind of gives rise to this t-shirt, right? There are that many types of people in the world, those who understand binary and those who don't, right? And while I was looking for the graphic to put this in, I saw another one. There are that number of people in the world, those who understand binary and those who have friends, which I'm not sure I agree with that, but I thought it was clever. Okay, so here's 3, right? I've got 1, 2, I've got 1, 1, add those up, that's a total of 3. For, what's that? That's 65, yeah, it's 164 and a 1, that is 65. And so then what's that? Someone's gonna get this so fast, you'll be amazed. How did they do it? How did they do the math so fast? Who's got it? Yeah, 255. How did you figure that out so fast? Because you took 1 plus 2 plus 4 plus 8 plus 16 plus 3 plus 255. That's exactly right. Well, what's the next number in this sequence, right? This is doubling every time. So 128, the next number over here would be, yeah, 256. And so if everything's full up to the right of that, it's 1 less than that next number. Because if I add 1 more into here, we go, oh, we've got 1 256 and nothing of everything else. So it's 1 less than the next over, right? So right, that's 255. So if I said, all right, I've got, and there is a data type like this that says, we're just going to store an integer value. I'm going to use just 1 byte. What's the range going to be? How big of a number, how small of a number and how big of a number could I put into that? Yeah, 0 to 255. And there's some other tweaking that we could do to say, well, if you really wanted to, you could make it go from like -5 to 250. You could kind of shift it, but you've got 256 different unique values. 1 through 255 and 0. So you've got 256, depending on where you start counting. So that's exactly right. Oh, where's my little clicker? So if I have twice as much RAM, twice as much memory, 2 bytes instead of 1, then I should be able to store twice the range, right? Twice as much memory should give me twice the range, right? Wrong. Why wrong? Yeah, because every extra bit that I get doubles the range. So now I've got the same on that first one. I've got 256 different unique values. I can have 0 to 255. And now I can have a 256 bit there, which that 1 bit now gives me the ability to go, oh, yeah, I'm not going to stop at 255. Now I can go how far? 0 to 511, 512 should be the next one. 256, 512. So 500, yeah. A 9-bit number is not one I think about very often, but would be, the range would be 0 to 511. And so, what would this be? That, I don't know, about 1,000. Yeah, I made the slides. So, right. And so, ultimately then, that's kind of what you're dealing with. If you want a really big number, more bytes, and every bit then doubles the range that you can store if you're talking about an integer. So here's the first data type that we already talked about, and it holds an integer, and the data type is byte. I think that's a really bad name for it, but that's what they named it. kind of nothing about it that lets you know it only holds integers. It's allocating 1 byte of RAM. Well, what are we doing with that? You just have to know it's only integers. Is this something that I'll kind of expect you to know for the midterm exam? Yeah. So much of what we do in VBA is just, can you do it? But really understanding how to work with memory is stuff, have you taken some time to learn the basics here? And some of the basic data types to work with are going to be important. So this is one you're going to remember, is that there's a data type called byte. It allocates 1 byte, that'll be easy, 1 byte of memory. And what's the range? You said it already, what's the range? 0 to 255. Can I put 1.2 in it? No, because it's only integers. So in fact, let's just come over here to kind of play with this. I'm just going to insert a module in whatever workbook I have here. Take off my caps lock so I'm not yelling. Variables. Now, we have a thing called the immediate window, which I'm going to introduce to you today. Control G brings it up, or you can choose view immediate window is your symbol, immediate window. The immediate window lets us do a couple of things. One, it just lets us, like execute 1 line of VBA code. For instance, I could say active cell dot value equals 5 and just hit enter on that. And it just says, you don't have to put that as a part of a sub procedure, right? Just hit enter on that and it executes that statement. So if I go back to my active cell, whatever the active cell was, is now going to have the value of 5. So the immediate window just lets me to kind of, it's like a playground. It's a testing place where I can say, what would happen if I tried to run this? And I don't want to have to run my whole program to get it to go. I can just type that line in the immediate window. But what we're going to use it for today is if I was to say print 5, then it would just put that here in the immediate window. To be able to access that functionality from inside of a sub procedure, I'm going to use an object and call a method. Someone remind me what a method is. You don't remember what a method is? Actually, let's do the easy one. What is an object? Thing. That's enough. That's all I want to hear. Object is a thing. What's a method? Yeah, it's an action that the thing knows how to do. And so the object, if we want to have down here in my sub procedure, if I want to put something in the immediate window just so I can see what it's doing, I could write it out to a cell in a worksheet. I just want to see what it's doing. This is the object. It's called debug. And the method is called print. And so if I say debug.print5 and then run this, it does the same thing. It just puts the output up into the immediate window. And so kind of using the immediate window and being able to say debug.print kind of allows you to see, hey, what's going on with my program right now? I'm wondering what would happen if I did this. You can show it to the immediate window. So that's going to let us just kind of see some things that we demonstrate here. So here's how I create that variable. So we talked about this data type here called byte. I'm going to come in here and I'm going to say dim. And maybe just quantity. Maybe I've got some, I'm dealing with some quantities that people are going to choose some amount. And it's going to be like somewhere between 1 and 20 or something. I'm not expecting them to want 5,000 of these. And so I think, byte would be okay. So dim QTY, that says, hey, that's the name of the variable. But remember, a variable has a data type, and that's what we just saw. This one is called byte. So I'm going to say as byte. Okay, so what this line says, so when the interpreter, which is the part of Excel that looks at my VBA code and says, all right, I got to translate this thing that's written in VBA, a language that humans can understand. I got to translate that into the language the computer can understand to actually to do what you're asking me to do. That's called the interpreter. It interprets what you write in VBA, translates it into machine code so that the computer can actually do what you're wanting it to do. So when the interpreter sees this line, it says, okay, great. I need to ask the operating system for some memory. Does the interpreter care where the memory is? Doesn't care. So it's going to say, and how much memory is the interpreter going to ask the operating system for? 1 byte, yeah. Now, it's not because it says byte. It's because the data type named byte only takes 1 byte. That's a bad, I really dislike this one. Maybe I shouldn't start with this one. But anyway, here it is. And so the operating system answers back. And it says, here you go. and it gives the interpreter, the VBA interpreter, it gives the interpreter the address. That is now at this location in memory. And the interpreter says, great, I'm going to refer to that location in memory. Every time my user talks about the variable name QTY, interpreter goes, I'm talking about that location in memory. We never see the location in memory. If you really, really want to know the address of where that variable is, you can get it. But you don't ever really want to know. You don't care, because knowing where it was won't help you anyway. So what we're saying is, hey, I need some memory. The operating system says, here's some memory, here's the address. And then the connection between the variable name, how you think of it, and the actual address, the interpreter takes care of it, you don't have to think about it. So now I can store a value in memory just by saying, like we did last time we were together with the assignment statement, but instead of saying like object.property equals something, I'm just going to say the variable equals something. QTY equals 22. And so now if I run that, I should be able to say debug.print. What do I put here? QTY. So now this is going to tell the interpreter, hey, give me some memory. This is going to say, plug the value 22 into that location in memory. And this is saying, hey, I want to print QTY, but it's not going to print the letters QTY. It's going, oh, that's a variable. I recognize that. In fact, when the interpreter looks at this line, it kind of goes, let's see, debug, what is that? And it kind of goes through a list of things. Is that an object? Is it a variable? Is it another procedure name? Is it a function? It goes, oh, it's an object. I recognize that. Go ahead.
So I just want to mention, I know there's also the data type being integer. So the difference here is with byte, you can only store integer functions with integer.
That's right. Yeah. The question is, hey, I did some reading before you came to class. There's another data type called integer. Well, wait a minute. These are integers. Yeah, byte is integers. There are actually 4 different integer types. There may be more. There's 4 that I can think of. And they all have different ranges. One is called byte, one is called integer, and we'll talk about the others today as well. So now if I run this, what should we expect to show up in the immediate window? Yeah, whoops, should be 22. Oh, almost like I've done this before. Okay, so now let's look at a couple different things. What would happen? What do you think? What if I put in, oh, first point, you know what, 22? What am I ordering? Maybe I'm ordering hamburgers. 22 is a lot. I could probably eat 22 hamburgers if I was really hungry, but today I can eat 22.5. Let's do 22.6. What do you think is going to happen? Okay, a respectable programming language, and I like to kind of poke fun at VBA a little bit. A respectable programming language would say, you can't do that. Right? It doesn't fit because you can only put an integer into this data type. VBA is not going to do that. Because remember, the theory behind VBA, or the whole guiding principle, is just make it work, right? Make it work. Okay, so if you're thinking, if I'm going to make that work, what do you think it's going to print? Either 22 or 23? Oh, I got to remember to be on it when I run. If you run 23, yeah. So the interpreter goes, you can't put 22.6. How close can I get? 23. That's the closest I can get. Is it going to give you a warning? That was an unusual thing to do. No. It's just going to say, hey, you're trying to put a 23.6 into a byte. I'm going to round it. So for those of you who are coming from other programming languages, this is a warning. This is not the kind of behavior you expect. But this is documented behavior. It's the way that the language is intended to go. Okay, so let's look at kind of some other ones here. I can put in 0, no problem. What's the top number? 255. Okay, now what is this going to do? Is this going to be an error, or is it going to go, you know what? The closest I can get is 255. Just do 255. Thank goodness this is an error. So let me run this one. And here's the error. It's a great error. Overflow. Well, actually, that's not a bad one. Because here, imagine when this is 255, this is all full of ones. What would happen if you tried to cram one more 1 in there anywhere? If you had a cup and it was completely full and you put more in it, what would happen? It would overflow. And that's exactly what happens here. So when you run that, you get this overflow error. Thank goodness VBA stops it and says, you can't do that. Otherwise, if it overflowed, what would happen to that extra bit? It'd fall out of memory, it'd roll around inside your computer, you'd shake it, you hear this little bit rolling around in there or something. Of course, that's not really what happens. Yeah, actually, what would it do? If it didn't give you an error, what would it do? It would change that back to 0, and whatever was right next to it in memory would get changed. Well, you don't want that happening. And so, so that's why we get this overflow. And so what overflow means is you try to put something into a variable that just won't take. That's what overflow is. And kind of until you understand what's going on in memory, overflow is like it's an absurd word to say. But that's the error message that you get. So how about, that's if we try to go over. What if we try to go under? What's it going to be, an underflow? Still an overflow, right? You tried to put something in that the memory can't take. Questions on this data type? Yes.
What's the difference between a variable and an object?
Question is, what's the difference between a variable and an object? So a variable, that's a good question. A variable is a location in memory with a name that can hold a value of a specific type where you can store a value and read it back later. It is only a value. So a variable is, it is one value location in memory. An object now will say, listen, I want to take 3 or 4 different values and kind of treat them together. Like these somehow are all connected to each other. And so what an object allows me to do is says, all right, I'm not going to just have one value here, but I'm going to have 4 different values that are part of this object. So it's like taking 4 variables, putting them together in an envelope, and saying, here's the object. Now, in addition to having those properties, which is what we would call them in an object, that's what a property is. It's a variable that's a part of an object, because it's just a place where you plug a value in. Objects can also have the behavior, can have the methods where they can do stuff. But in terms of just managing data, that's the big difference. A variable is just a single value, whereas an object is a collection of multiple values, each with their own name. Okay. Other questions? Range 0 to 255. So if we've got 2 bytes now, this is going to be a different data type. This is going to be integer. This is the one that you're asking about here. 1, 2, 3, 4th row, center student. And so 2 bytes is integer. And I think we're going to talk about the range here, unless I accidentally moved it. If not, we'll come back to it and talk about it. Okay. So now let's just kind of take a look at this kind of view of memory again. So if we could just kind of look at all the memory at once in the computer, and of course, this is just a tiny little bit of memory. And so now I'm showing some of these in gray. So what the gray means is that the gray here is parts of memory that the operating system has handed out. This is memory that this right here, this little block here in gray, the operating system has given that out. It's not available. If VBA asks, for an integer variable, it can't show up here because this belongs to some other program, right? So it's got to be somewhere in the part that's not highlighted. That's kind of what I'm trying to show you here so far. All right, so that one little location has an address. That one has an address. Here's that address in decimal. Here's that address in, so decimal base 10. Here's the address in hexadecimal base 16. And we typically think about memory addresses in base 16 in hex. In this class, we don't think about memory addresses after today, not even for the midterm. All right, so this is just trying to get, yeah, so who's breathing a sigh of relief right now? Whew, I'm glad I don't have to think about that. In fact, do we ever deal with hex? I don't think we ever deal with hex in this class. Right, here's the next one over. It is the next number up. It is just the next bit over in that. So when I say dim x as integer, the operating system is going to find some memory that's not already allocated to another process. And it's going to say, now, how much do I have highlighted there? How many bits are highlighted there? Yeah, 16, because it's 2 bytes. Each byte is 8 bits. And so it allocates 16 bytes. And then it goes, oh, here's the address. That's what the operating system does. This is the memory. It's going to say that's now allocated to whatever process just asked for it, in this case, VBA or Excel. And then it's going to send back the address. And the interpreter then keeps track of the connection between the address and the name that we gave it. Yes.
As far as clearing up the storage, or when the computer does. So when we created the quantity variable, right? would that, I guess, when would that memory be available?
Ah, good question. So the question is, let me just repeat the question for you here, and you'll tell me if I got it right when I repeat it here. So, hey, so you've declared this variable here, but when does it actually get declared? And more importantly, when does it get released? You know, how long is that available? Now, we're going to, later in the course, we're going to talk about how we could declare variables in different places to make them stay around longer, shorter, or longer. But when I declare a variable inside of a subprocedure, it becomes available just as soon as this subprocedure starts to execute. So is it allocated right now? The answer is no. And so when I hit play on this, whoops, let's go ahead and put it in one that doesn't fail. It did allocate the memory there. When I hit play on this, it says, give me the memory, put one in it, read the one out of it, and then it gets to the end sub and it goes, we're done with that memory. Poof, gone. Well, the memory's not gone, it's there. But at that point, when we get to the end sub here, the interpreter says to the operating system, hey, I'm done with that. And it goes, great. You know, if someone else wants it, it's there for me to use. If you want it again, I'll give it back to you. So what you're talking about is called the scope of the variable. How long will it stick around? You know, could I have a value here and have 3 or 4 different procedures run independently from each other and still access that one value? The answer is yes, but it's beyond what I'm showing you today. So today is just understanding the idea of what a variable is. Other questions? So how is VBA going to represent a negative value? So far, we've seen how to represent positive values. How do we do a negative value? And here's the answer, is you're going to take some stored value, you'll store some integer, the same way that we've seen store integers, and then we'll say, all right, what we're going to do is we're going to, instead of just assuming that it's going to start at 0, like the byte type does, the integer type, which can hold negative numbers, we'll say we're going to store an integer value there, but instead of adding it to 0 to see what the real number is, we're going to add it to some other value to start. And it happens to be negative 32,768. Do you need to know that for the midterm? No. But that's like the bottom range. The lowest number that you can put into a variable type integer is negative 32,768. Here's proof. Let's change this to integer. Let's put into it negative 32,768. We'll run that. It prints out fine. We try to go one lower than that, and we run that overflow. That's the bottom. So if we kind of have a whole bunch of zeros stored, then that number will be negative 32,768. Now in this case, the number that I have stored here is 1,000. So that's the integer that's kind of just stored in binary. But if this is a variable of type integer, what value is actually represented there? And the way it works is we start with the very bottom number, negative 32,768. We add the 1,000 that's represented in memory, and we come up with negative 31,768. So that's how we get, that's how negative numbers are implemented. Instead of starting counting at 0, for the integer type, it starts counting at negative 32,768. So if I'm storing the number 32,767, what number is that? That's -1. That's what -1 looks like. If I actually store that number, what is it? That's what 0 looks like. Do you really care what 0 looks like? No, not at all. But that's what's going on in the background. That's how we can do negative numbers. So this is, I'm storing 33,768. That's how 1,000 is actually stored. How many of these can I possibly do on this slide? Oh, so that's all the way full up. So that number is 65,535. And that's going to be the upper boundary, right? Completely full. Start counting way down there at our lowest index, add the 65,000 up to it, and it gives you 32,000. So what's the range for integer data type? Yeah, negative 32,768 to positive 32,767. That's the range. So if we come here and put in 67 and run that, it runs just fine. We try to put the 68 in there. Oops. And that's an overflow. And that is then the integer data type. Now, I am going to expect you to understand something about it. And this is kind of how I'm going to test you on this. I'm going to say, suppose that you need to declare a variable that can hold a value between 1 and 100 that's an integer. What's the best data type to use? First of all, could you do that with integer? Yeah. Is that the best data type to use? No. Why? Because you could do it with less. And what would be the better one? What would be the better choice? Yeah, use byte. Byte is 0 to 255. So 1 to 100, no problem. I don't want to, feel too much about this, but you've got billions of these. Are you really caring about having one extra one allocated? Well, as it turns out, later in the class, I'm going to show you how to declare tens of thousands of variables all at once with one statement. Tens of thousands of variables. Once you start declaring tens of thousands of variables at a time, is the difference between having a few extra bytes on each variable important? That might become important. But at this point, you might go, wow, we're arguing over a byte? No, not really, but we're just kind of building the foundation. Questions? Okay. Next data type. So we have a third integer data type. It is called long. It is short for long integer. So byte is 1 byte, integer is 2. Oh, by the way, on integer, I'm just going to expect you to know roughly plus or minus 32,000. You don't have to get down to the specifics on this, but being able to know, I got to put in, maybe I'm doing, zip codes. Could I use an integer to store a zip code? US zip code? Who's from Washington State? Anyone? What's your zip code in Washington State? 99352. Is that bigger or smaller than 32,000? It's bigger than 32,000. So I can't store all US, I can't be sure that I can store a randomly chosen US zip code into an integer type. Okay, so now long integer, instead of 2 bytes, it's 4 bytes. So what's the range here? Kind of the same structure under the hood. It's roughly plus or minus 2 billion. So if you're dealing with numbers, in the range plus or minus 2 billion, long integer is going to be fine. Could you do the national debt with long integer? Not even close. Okay, now there's one other integer data type that we're not going to use. It's called long. That's a really crazy name, isn't it? The largest numbers that integer type we had prior to the 64-bit version of Excel was long. But now, once they had a 64-bit version, they thought we got to at least have one integer for every possible memory address. And so they made a new type called long. It's not an ordinary long, it's a long. You don't have to worry about that one. It's bigger. How much bigger? A lot bigger. That's available. But it's really just used if you have to do some things with memory addresses. Okay, so how about a decimal? How do we do decimal values? So there's a couple different approaches, and we'll see there's different data types. So the first way it does it is say, well, just same way that we've seen to store integers that way. Just use binary to represent some integer. And then we'll say, we'll just know that integer has, that the decimal, whatever that integer is, count over 4 from the, let's see. I got to think about how this looks from you. For me, it would look like this. Count over 4 from the one side, and then put a decimal. Anyways, there's always 4 decimal points of precision. Another way to say that is divide the number by 10,000 to move the decimal point over. And so that's pretty simple. It doesn't take any extra memory because the decimal point always goes in the same place. And so let's suppose that there is no 2-byte floating, 2-byte fixed point number, but just for discussion purposes, let's suppose that we had this number all full of 1s, but instead of being a data type integer, by the way, what's this value if this is a data type of integer? If this is an integer, about what's the value here? Yeah, 32,000. It's full up. It's 32,767, but it's about 32,000. But in a fixed point scheme, which is what this is, we're going to take that number, we're going to divide it by 10,000, and we're going to say, that number would be 6.5535. Right? So it's the number that we have represented here, and then we're going to say, we have 4 digits of precision, and so the decimal point goes right here. So there's So in a fixed point number, you always have 4 digits of precision. Well, what if you don't need any decimal points for it? Well, then you're just not using the decimal point, but you're still storing it the same way. You're putting in, 10.0, and it handles all the storage behind. So when you ask back, it comes back 10.0. What if you want to put in 5 decimal points of precision? It'll round it, right? Just the same way that we rounded the value when we tried to put a decimal point into integer. Some other examples here. We've got those numbers. You divide by 10,000, there's 5.5. Okay, so that data type that we're talking about is called currency. So if I declare a variable as currency, we'll just take a look. We've seen integer. We could declare this as long. This will, right, this had an error when it was integer. That should print just fine as long. We should also be able to do this as currency. CURRENCY. And that works there as well. But now we could put on here 4 decimal points of precision, and it will remember them. What happens if we try to put in another one? No, it just won't remember it. It'll round it. Yeah. So if it's inside the boundaries, and it's it's not right, it will round. If it's outside the boundaries, it'll say you can't do that. Can we do the national debt with? No, not even close still, not even a trillion, right? Close to a trillion, but not. Okay, the second approach, so that's called a fixed point number. It's just a number where we say there's a fixed number of decimal points. You just store the integer, and the interpreter goes, oh yeah, I got to remember there's 4 decimal points. So when you ask for this number, I'll read the number and say 4 decimal points of precision. The other one is called a floating point number. We're going to use part of the memory to tell us where the decimal point goes. So up here, the part that I have up here set in green, we're saying, listen, part of this tells us where the decimal point is. So what do I have here? I've got a bunch of 1s and 0s in the blue space where I'm saying that's where I'm keeping track of the number, 3,574. But where does the decimal point go? And right now this says 0 places, there's how many digits are to the right of the decimal point? The answer is 0. If we change that, we say, oh, we're now storing in the green area here, we're storing a 1. We're saying, oh, there's 1 digit to the right of the decimal point. Here's 2 digits to the right, 3. Here's the most we could do in this scheme is 15 decimals to the right of the decimal point. To the right? Yeah, to the right. That's called a floating point number. And it takes then some memory to tell us where the decimal goes. So the type then that we have for this is called single. It's 4 bytes, and it means single precision floating point number. So we can come in here and we can call this single. We can run that. And now, make it clear what we have here. And now we get 32,768.11. How come we have fewer decimal points? How come we have fewer? Why did we lose 3 of those digits? Because we have enough memory to store a number, and that number is something, and then we've got the part that tells us. We're using memory a little bit differently here. And so the range, plus or minus, I don't know what that number is. That's the range. But the kicker is you only have 7 significant digits. So we've got 7 digits that we can keep track of the number, and then we can push the decimal point either to really precise. We have lots of digits behind the decimal point, or we can go really, really big, but we can't be really big and really precise because that's what the range is. Questions? So that's the type single. There's another one that's twice as big called a double precision floating point number. That's the range there. This one can finally, we can handle the national, truth is, we can handle the national debt here. This one will handle the national debt, but could it handle the national debt perfectly? I don't know. Let's see, there is that's 1,000 million. Yeah, it could. There are enough digits that we could, actually do the decimal point down, or the national debt at least down to the dollar. But we got lots of room, to go here. But you kind of have the same thing. We can store a number and then we can push the decimal point in either direction. So the actual implementation of single and double is a little bit more complex than this, but this gets you going in the right direction. And we don't really get more by understanding it more deeply. Okay, so we have another data type. How do we store true and false values? This one seems a little bit weird. So VBA stores 0 to mean false, and it stores -1 to mean true. Almost every language that I've seen stores 1 to mean true. VBA stores -1 to mean true. I don't have a good excuse for that. In fact, I was reading about it today. I thought, you know, I've never had a good answer for that. Maybe I'll find a good answer for this today. So I was reading about it today. I still can't find a good answer. I think I understand a little bit more, but it's kind of more than I want to dig into here. So this is weird. To store true and false value, only 2 possible values, VBA is actually going to allocate 2 bytes of RAM for this. And it's because it's going to kind of under the hood, it's going to use an integer to store it. And it's the smallest one that we can do a negative number in is integer. And so, you know, there's 0, which is false, kind of, you know, using integer scheme. And then there's 1, I'm sorry, there's -1, which is how it stores true. So, but what do you need to know about Boolean? It's true or false. Interestingly, in terms of implementation, we're going to do something similar to the rounding that we did before. Let me just leave that one there and make another one. Variables 2. Let's dim hired as this data type is Boolean. Isn't that a strange word? Boolean. Boolean. It's actually named after George Boole, who was an 18th century mathematician who did a lot with kind of Boolean logic. Developed, well, it's named after him. So kind of, you know, dealing with mathematics on logical values, true and false values. Did you ever learn a truth table like when you were in high school geometry or something? Like T and T equals T, T and F equals F. How many learned that? A few of you. You have George Boole to thank for that. He's long dead and you can't curse him. Well, I guess you could. Okay, so we've got hired as a Boolean. And so I'll say hired equals false. And then I'll print hired. Okay, false, not a big deal. Of course, we could change that to true and it would print true. But here's the interesting thing. I'll print that to 0. What do you think? Yeah, the real question is error or not error? And the answer is because under the hood, what it's dealing with is that number, it takes the number just fine. And it goes, oh yeah, okay, we can put a 0 in there. So -1 then should be true because that's how it stores it internally. There's the true, but how about 200? Yeah, also true. 0 is false. Any other number is true if you're doing kind of conversion. Okay. How about dates? So this is really kind of similar in concept. We're going to store an integer, and then we're going to say that's a number, that's a certain number of days past some arbitrary starting date, which happens to be December 30th, 1899. When you're trying to make up a data type and you're thinking we got to have a place to start, why do you choose December 30th, 1899? I don't know. What's the significance of December? It's not the end of the year. It's like the day before the end of the year. It's like New Year's Eve. 1899. I don't know. That's what it is. So, you know, if we store a certain number of days, what that really means, if the data type is date, it is that beginning date plus that many days equals the bicentennial, July 4th, 1776. How about date and time? It's the same thing, but now we're going to store, instead of an integer number of days, we're going to store a floating point number of days. So it's going to be, you know, in this case now we're talking about the number, the whole portion of the number getting us to the day, and then the fractional portion of the number getting us to the time. So what portion of a day, you know, that is 0.375 of a day is 9 o'clock a.m. So that's how we do dates. And there's a data type called date, and you could write numbers to it again. If you ask it back, it'll tell you the day that you're talking about. So believe me on that, we just won't do it. Questions here? Yeah, so the date type is actually a date and a time. How about a name? How do we do names? So far, all we've dealt with has been numbers. So what we're going to do is we're still going to store numbers. Ultimately, everything has to get down to ones and zeros. And so to store a name, we're going to say, all right, we're going to actually allocate 1 byte for every character. So here we have 65. 65 is capital A. And the interpreter just knows, oh yeah, 65, that's capital A. What do you think capital B is? 66. Yeah, capital C is 67. There's some logic here. So if I was to kind of turn this memory representation on its side, so there's 65. And then if I was going to do John Adams, I've got the A is represented by 65. The lowercase d is 100. The lowercase a is 97. Each one of these characters then has a different number that represents it. And so I'm storing in memory all these ones and zeros to be able to store John Adams. That's how it's stored. Do you have to care about ones and zeros and converting back and forth between the numbers and the, no, you don't. But that's what's going on underneath. Questions? Will this be on the test? Yeah, it will be on the test. It'll be on the test in the sense, what would be the best data type to use? I'm gonna give you a list of data types to choose from, A through J, whatever the testing center lets me do. So you got to store, you got to store people's names. Which of the data types is going to be your best choice down here to choose from? So that's the level that I'm asking you to understand. Okay, so the American Standard Code for Information Exchange is what defines what each number is here. So here 65 is capital A, 70 is capital F, 115 is S, and that's just a standard. It's just the standard that we follow. Interestingly, the first 32 characters are non-printable characters. They're actually codes for controlling physical hardware. It's really amazing to me, and you use these almost never. They end up getting used almost never. But if you ever watch a movie that is like set in a newsroom, like in the 1960s, 70s, or early 80s, you've got folks are in the newsroom. You hear all this kind of clatter just going on in the background. And that's actually like teletype machines where distant reporters are sending in their stories, and they're sending in these sequences of numbers, and it's controlling a physical machine that's typing out onto paper. Gets to the end of a line, the next code, in fact, what is it up there? 13 is character string, yeah. So we said, oh, we're right to the end of the line, send it to 13, and when the machine receives a 13, it sends the print head back. And if it just starts typing again, it'll start typing again right across the same letters it was there. And so number 10 up there is a line feed. And so the 10 says advance the platen. We don't need those numbers for the way we use all those beginning ones. We use them almost never. 10 and 13 still get used to kind of indicate the end of the line. But it's a standard. Once you have a standard in place, it's tough to move. So do you ever need a vertical tab? Number 11. I don't even know what a vertical tab is, but there you go. So yeah, there's 65. Now, interestingly, so far of all the data types we've talked about, when you allocate the memory, when you say dim QTY as integer, 2 bytes of memory get allocated, and that never changes. It's the same 2 bytes you're dealing with. If you put another number in there, it just writes over the top of it with those values. But now, for character data, the data type is called string. For strings, how much memory we use depends on what we put into it. And so the first thing that happens is we say, we're going to take 4 bytes. It's just going to be overhead. 4 bytes here is going to tell us how long the string is. Just a number that says how long the string is. And then we'll have that many more bytes. So right here, we have represented up there 11. So this says the string's 11 characters. And then the next bytes in RAM are the 11 characters. So when the interpreter goes to read that, it says, go to the place where the memory starts, first read how long it is, and then read that many more characters to be able to pull the data out. So that's the data type string, 4 bytes of overhead plus 1 byte per character as you're storing. So if I was going to plug John Adams in here, or actually if I was just going to declare name as a string, it actually allocates 4 bytes. Did I highlight it here? Yeah. It says, all right, here's 4 bytes. And when you declare the variable, what's in it? There's nothing in it. It's just empty. And so those 4 bytes are full of all zeros. There are no characters. How much RAM gets used by an empty string? No characters in it. How much RAM is used? 4 bytes, because there's 4 bytes. There's 4 bytes to say it's empty. It's a lot to say it's empty. That's how it works. Now, when we go to say John Adams, if we're going to put John Adams into this, now say name equals John Adams, can we just say, oh, we need 11 characters? Wait, 1, 2, 3, 4, 5, 6, 7, 8. We only have 8 more. Well, actually, that's 1 more character. We have 1 more byte here before we run into some data that's already allocated to something else. Can we just extend this then? The answer is no, because if we tried to add on 11 more bytes, it would overwrite the top of this. So every time we write a string, every time we change the value in the string, it's actually going to find a new place in memory where it can all go contiguously, and it's going to put it in that place. It'll become important if you ever have to deal with like writing a same string over and over and over again, because it's going to be pretty inefficient. Question?
Does that mean the first set that all the zeros then can be overwritten? Does the memory then?
Yep. So the question is, so does it, this first one that was used when we declared the variable, does that get then freed up? And the answer is yes. That's like, you know what? We don't need that anymore. You can do whatever you want with it. Then VBA gives it back to the operating system. So what would happen if we, want to put a lot longer string into it? Well, if it would all fit in here, the operating system might give us back this same spot, but it might just, we don't really know. It'll just give us, we say we're changing the string, and this all happens in the background. The operating system says, here's some data that will store this, or here's a place that you can store all this contiguously in memory, and the interpreter handles that for us. And so that takes the 15 bytes, 11 bytes for the characters, 80 AMS, comma, space, John, and the 4 bytes for the overhead. Okay. There's another data. So these have all been primitive data types, just data types that hold, in fact, variables themselves all only just hold a value. There's another kind of data type called object. And object just holds a value as well, but it's a little bit more complicated. So remember, objects, they're like multiple values together. So we had the question before, what's the difference between a variable and an object? So here's like an object. I'll call this range A2. It's got, I'm only showing these 5, it's got dozens of properties. It's got dozens of variables collected together into one object. We call those, when we have those variables built into an object, we call them properties. That's what properties are. And so there's lots of ways to refer to where this object is in memory. If my active cell is on A2, I could say active cell. I can say range A2. There's another method called cells. We say cells, let's see, it goes row and then column. So that's row 2, column 1. So cells 2, 1 would be another way to refer to that. So what an object variable is then, is an object variable allows me to say, I want to have a shortcut to be able to refer to that other object. I want to have a variable that just holds the memory address for where that object is. That object is sitting in memory somewhere. And when I say active cell, the interpreter has to go through some logic to say, all right, I got to figure out where the active cell is. It finds the memory address where that thing is, and it hands that back to the interpreter, says, this is the object you're working with. That's that location in memory. Well, we can remember, we can find that location in memory and we can remember it. And that's what an object variable allows us to do. So here we could say dim range as an object. This is the data type, object. And then when we're working with object variables, we have to use this keyword set. This is going to feel like to you a little bit, is it too late to drop the class? Here, this is a little bit more complex. At this point, we're going to go over this several more times till you get comfortable with it here in the class. But now we're saying, here, this is saying, here's a way to refer to that object. I just want to remember that. Remember that the object located that gets found by this, I'm going to call RNG. So now I can say RNG.value equals 22, and it will change what's in range A2. So an object, you can think of it as saying, you know what, I just want to make a nickname for the object, kind of a quick way to be able to refer to that object. Because this might be long. Instead of just range, because by the way, how many worksheets do I have in the worksheet, in the workbook? Could be more than one. So how many range A2s are there? Yeah, one on each worksheet. So I might have to say, oh, I'm talking about a specific sheet, so the sheet called employee compensation, range A2. But how many sheets called employee compensation could I have? Can I have 2 worksheets in the same workbook with the same name? No. Can I have 2 workbooks open at the same time? Yes. And so I could have 3 or 4 different worksheets all with the same name. And so I have to say, all right, in this workbook, in this worksheet this cell. And I have this kind of this long way to identify the range I'm talking about. Can you see why it would be helpful to say, I just want a short way to refer to that? And so object variables are like nicknames. You figure out the variable you want, the object you want, and then you can give a name just to that variable. By the way, could I even go further than that? Could I say, I've got 2 different instances of Excel open, and in this instance of Excel, I've got this set of workbooks, and one of those has this worksheet, and one of those, yeah, you can do that. I mean, it really can get complex. And so a range or an object variable just allows us to refer to that object, with a shortcut, and that's what that is. Let's just see that one happen. So let's do another, and this will be the last thing we do today. We'll call this object variables. In range as object. Set range equal to the active cell. Range dot value equals 33. Oops. Okay, so when I run this right now, active cell is going to figure out which range are we talking about. When I run this, which range is active cell going to refer to? Yeah, that'll be B3. So when I refer to range later, it'll be B3. If I run it over here, it'll refer to that one. Now here's the kicker. What if I say, let's just say this, range A1 dot select. Okay, so now the question is, when I run this one, which cell is going to get the value 33? Right now, I've got C4, very explosive cell. I've got C4 connected here with my active cell. So this will be refer to C4. But now, before I refer to it, I'm going to say, wait a minute, make a different cell active. So when I say rng.value equals 33, will it do what was active when I started running this, C4, or what's the active cell when this line gets executed? Which one do you think? Who says it's going to do A1? Who says, no, C4? No, C4 is a little bit slightly more popular. And C4 is the correct answer. Because what this is that this now gets evaluated. It says, what object is that? And we're going to remember the object. That's the object located at that location in memory, and that's what this refers to. So we change this to somewhere else. This is not a nickname for the active cell method. It is a nickname for whatever that active cell evaluated to, the address that identified. Oh, it's uncharacteristic for me to let you out a full 3 minutes early. So I should ask, are there any questions? Seeing none, we'll dismiss class. Oh, we actually had folks watching today. Excellent.